I am Garret Arcoraci, at least that's what my license plate tells me, or my driver's license. So I'm going to talk about SLAAC, not Slackware, SLAAC, which is IP version 6 related, and it means stateless address auto configuration, which is just a fancy term for, let me turn my mouse on here. It's working. There we go. All right, so stateless address auto configuration. It's just a fancy way of saying, hey, I'm an IP version 6 host, and I can create my own IP version 6 globally routable IP address, and I don't need any help from anybody. That's really not true, because you need to have an IP version 6 configured. Anybody? Router. Right. All right. So IP version 6, this is really interesting because just like IP version 4, I'm going to go on the assumption that most people here are pretty familiar with IP version 4. No? It came before IP version 5 and after IP version 6. No, it didn't come after 6. No, IP version 4, just like IP version 6, you can configure your IP address statically, or it can be done dynamically. But we know in IP version 4, at least most of us know, IP version 4 needs a little help. It needs help from a DHCP server. Okay? Sometimes the DHCP server can give us more than just our network, our gateway, our DNS server, maybe our domain. But when it comes right down to it, if a device wants to communicate with other devices in an inner network, or maybe over the internet, it just needs to know the network that it belongs to, which is done in IP version 4 through a logical address or a layer 3 address or an IP address. And at layer 2, it uses something called a MAC address or a hardware address, which is burned into, typically it's burned into a NIC card. There are some software implementations where you can create a MAC address for a device, but each network interface in the entire world should have a very unique number, which is 48 bits, known as a MAC address. So in IP version 6, we have a 128-bit layer 3 address, which is really good because we can take a 48-bit MAC address and we can stuff it into, in some way, shape, or form, into our 128-bit IP version 6 address, which you really can't do with an IP version 4 address because an IP version 4 address is 32 bits. So you can't really cram 48 bits into a 32-bit address. So basically in IP version 4, our two addresses at layer 2 and layer 3 are disassociated with each other. All right? But in IP version 6, as we'll find out, you can actually take and have some type of association between those two addresses. So if you're looking for a formal definition of what SLAAC is, basically it allows an IP version 6 device, or host, all right, to create a global unicast address, which means it's just a fancy way of saying, hey, I got an address that can be publicly routed over the internet or between internetworks. Right? So here's a quick review. We can assign it statically, just like IP version 4. We can use a stateful DHCP version 6 server, which means that DHCP server can provide the information that the host is looking for. All right? Or we can use something called stateless or the neighbor discovery protocol. All right? And when it comes down to it, even though a DHCP server can provide us with a lot of information, the host doesn't really need it. It needs to know basically three things. It needs to know its network prefix, okay, or its network address. In IP version 6, that's referred to as a prefix. It needs to know the length of the prefix, so it knows how many bits are actually being used for the network portion of its address. And then it has to know its gateway. It has to have some way to get off of its local network. So the bare minimum for a device to get off its network is a prefix link, a prefix, and a gateway. If it has those three things, it can get off a network. All right, DNS is a nice, helpful tool for human beings, but as far as machines go, they just deal with numbers, and the addresses that are provided at layer 2 and 3 are enough to do that. All right, so we have something called the Neighbor Discovery Protocol, and essentially that protocol is used by IP version 6 for devices to communicate between the routers and other neighbors on the network. Now for stateless address, or SLAAC, I'm going to say SLAAC because I can't remember the acronym, stateless address auto configuration, really most of the work is done by routers through router advertisements. So in other words, the IP version 6, or the IP version 6 configured router will tell the host devices in its local network, okay, or in IP version 6 vernacular, its local link, or link local, that, hey, I have the information you need, the bare minimum information. But there are different options. So these are the 4 messages. We have redirects, though I should say there's a 5th one, which is a redirect. But as far as SLAAC is concerned, there's 4 messages it's really concerned with. And the major one is router advertisements. We also have router solicitations, where a host device could solicit the information from a router, right? Router advertisements are basically routers periodically sharing that information with devices that are local to its network, right? We also have neighbor solicitations, where a host device will basically ask other host devices on the local link for their information. And we have host devices that will freely give out the information about what they know on their network, right? And in most cases for SLAAC, router advertisements are very important and neighbor advertisements are very important. There's something called duplicate address detection, or DAD for short, that the IP version 6 host devices will use to determine whether or not another device on their local link has the same IP version 6 global address that they have. All right. So router advertisements now basically can be broken down into 3 options. All right. Option 1 is SLAAC with no DHCP, which just means that that host device is getting the bare minimum information it needs from the router. The 3 things I mentioned before: prefix, prefix length, and gateway information. Option 2 is SLAAC plus a DHCP version 6 server somewhere on the network, just in case the other device needs to know DNS information or other information, right? There may be a web proxy server out there that those devices need to know about. It may need to know its domain. It may need to know an IP address for a primary or secondary DNS server. So that's why you may need to include a DHCP version 6 server. And then of course I got a spelling mistake here in the acronym. But option 3, that should be DHCP version 6. Option 3, of course, is exactly the same as IP version 4, where the device or the host device asks a DHCP server for all the information it needs. Luke.
So for option 1, I guess there is, you just don't have DNS?
Yes, option 1, because you'll find out why. You'll find out why you don't have DNS. Although it's not entirely true, because basically with option 1, you're relying on the router or the Cisco device or the DHC or the IP version 6 configured device to provide all the information that the host needs. And Cisco routers can be configured with DNS information. So this option right here, there's messages in the routing advertisement that they're basically flags. There's other, and then there's message, and I'll go over that shortly. But you'll see that the Cisco routers can be actually configured to work as a DHCP server. And we see that now too with a lot of software type router implementations where you can configure that information. And basically, your modems at home act as DHCP servers. So it's really nothing new. It's just a different way of implementing it in IP version 6. So in the router advertisement, you have two messages. You have an M flag, okay, which is 1 bit, and that essentially it's the management function of IP version 6. And so again, it's a flag that essentially tells a router when to send the router advertisement. When you do that, if this flag is set, then basically what you're saying is that we're going to manage what information we provide to you, okay? The O is other, okay? And this basically tells the router that when it sends a router advertisement, if you set this flag to 1, then you're letting the host know that if there's other information that you need to get it from a DHCP version 6 server, all right? And that's what those flags are for, and then the remaining 6 bits in that byte are reserved. By default, Cisco routers will have both bits set to 0, and what that means is that if we set both of these bits to 0 on the next slide, that means you're using SLAAC. So, right? So, basically with management, we're basically telling the host device, I don't have any of the information you need. You need to get everything from a DHCP version 6 server. And if it's managed, or if it's other, I can give you just what you need to get an IP version 6 globally routable address, but for other information, go to a DHCP server. All right, so by default, Cisco routers are configured to have the other flag bit set to 0 and the management flag bit set to 0, in which case no DHCP server version 6 servers are involved and everything comes from the router. All right? If I have the management bit flag set, I'm using only the DHCP version 6 server, and if I have the other bit set, that means it's a combination of I'm going to give you some information that I know, and then the other information you're going to have to get from the server. And if we look at a trace, you have to remember, like, IP version 6 is unique in that the neighbor discovery protocol is actually part of the ICMP version 6 protocol. So all neighbor discovery, router advertisements, router solicitations, neighbor advertisements, neighbor solicitations, all of those things are encapsulated in the ICMP version 6 message. So if I pull up a trace, all right, and we drill down into a router advertisement, you can see here's the Internet Protocol version 6, okay? But in the ICMP, the Internet Control Message Protocol, this is where I have my flag set. And you can see that both flags are set to 0 here for both the managed address configuration and the other configuration. So in this trace, the Cisco router is essentially set to the default settings, right? And you can see I have the router advertisement being broadcast. Well, actually, it's multicast, all right? And I also have neighbor solicitations and neighbor advertisements. All right, so back to the presentation. If I can find my mouse. All right, so as I mentioned, the question we really need to ask ourselves, what is that router providing to me? And it essentially provides you with your network prefix, which defines the bits that are being used for the network portion of the address. Now, most cases, because there are so many IP version 6 addresses available, and there's a lot of different analogies out there that describe it, but let's just say that it's fairly safe to say that we'll never, ever, ever run out of them. Of course, they did say that about IP version 4, but IP version 6 is an entirely different story. In most cases, the prefix is going to be the first 64 bits of the address. Okay. Now for North America is getting 2001. All right, and then it's up to the ISPs and everybody else to decide how they're going to break up that address space. All right. Then they pass it down to it gets passed down to the regional internet registry to manage. In this case, it's ARIN. And then from ARIN, they pass it out to the internet service providers, and then the internet service providers will then break it up as they see fit between companies and residential users. Right? So the router, if it's configured for IP version 6, you'll see an address similar to this, a hex notation, and then you'll also see / notation, which tells me that the first 64 bits are being used for the network portion of the address. The remaining 64 bits will be used by the host to create its own MAC address. And there's two ways that typically hosts will implement this. There is a specification defined by the IEEE called the Extended Unique Identifier 64, and it's a very quick and easy way for a device to create a MAC address to be used as part of the globally routable IP address for IP version 6. There's also another method where you can randomly pick your MAC address, and that's probably a better solution since it's more secretive as opposed to an EUI64, which I'll show you very quickly how you can create one. All right, so the client basically needs to know its layer 2 address, all right? And because IP version 6 doesn't rely on the standard 48-bit MAC address that gets split up between the OUI, which is the organizational unit identifier, and then the remaining 24 bits, which are the vendor serial number, all right? We need to come up with a extended or a 64-bit MAC address. But sometimes it's the EUI64 is an IEEE specification. The random generated number is sometimes called a privacy extension identifier, and I believe that was defined by RFC 4941. I have it at the end of the slide just so we can check it at the end. All right, so the router advertisement will multicast out to all IP version 6 devices on the local link. All right, it'll let those devices know its link local address or its gateway for that interface. All right, it'll also provide the prefix, all right, and the prefix length. All right, so what all the client has to do is figure out what its MAC address is going to be. In this case, what I've done here is I take the default MAC address for that client, or the MAC address for the interface on that client, and then I've created the extended unique identifier. And to do that, there's two things you have to do. Basically what I've done is split this address up between the OUI and the vendor serial number, and at this point it's 48 bits. So what I have to do is cram in 16 more bits, in which case all you have to do is add an FF and an FE right in the middle. Right? The other thing you have to do is take the first byte. I don't think I have. The first byte, which in this case is 00. So this is going to be very easy. That first byte is basically 00000000 in hex. And the 7th bit gets complemented. So basically this bit becomes a 1. And then I convert it back to binary. So now I have 02. So you can see that this turns to 02. And that complementing the 7th bit of the first byte of the MAC address is what lets devices know that this is a modified EUI 64-bit MAC address. All right, so that's how other devices know, basically, that I'm not dealing with a standard 48-bit MAC address anymore. Does everybody follow me on that? Mm-hmm. Okay. Or you can randomly generate one. If I were to do IP config on this, basically I can look and see, here's my IP version 6 address. So you can see this piece of it right here, all right? That is the network prefix, or the network portion of my address. And then over here is my EUI 64-bit address. And a very quick way to tell whether or not you're dealing with an EUI 64-bit address or you're dealing with a private address or a randomly generated one is you won't see the FFFE there. Right? Very quick and easy way to determine that. All right? So I have my IP version 6 globally routable address. I have a linked local address, which is usually defined by FE80, and then I have my default gateway. So now I can start talking to other IP version 6 devices, both locally and off my network. So this is the one with the privacy extension, and as you can see, as Windows Vista and later, Windows implemented the privacy extension, and Mac 10.4 and later implements the privacy extension. So I think for security reasons, they're going to have a random number, which is probably better because you can easily take an EUI 64-bit MAC address and figure out the local device's MAC address as well as the network prefix and know exactly how to find that device or figure out where that device is located, at least in the internet. All right? So, does anybody see a problem with the randomly generated MAC address?
What if there's two that are the same?
Okay. Now, the RFC, believe it or not, does not make it mandatory that you use what's called duplicate address detection. It recommends it. And here's why it recommends it. Because you have a 1 in 18 quintillion chance of having a duplicate privacy identifier or random number. So it's recommended, it's not mandatory because the odds are very slim that you would get the same randomly generated number. But what data duplication does, or data address detection does, is it basically functions the same way that a gratuitous ARP and IP version 4 functions. This is where, up until this point, everything that's happened has happened through router advertisements. Okay? Now, we got to send a neighbor advertisement. So the host device, before it does anything else, will multicast out that new IP version 6 global address that it's created to the local network, and then it'll say, hey, does anybody else have this address? All right, so I probably should go to this slide. So this local device sends out a neighbor solicitation out to everybody else, asking them, does anybody else have this same exact address that I just created? It starts a little timer, okay? And if it receives an advertisement back from any other device on the local network, then he's very unhappy because now he has to create a new number, all right? But if the timer expires and he never receives an advertisement from anybody else, then he's happy and he knows that he can use that address that he created, right? So that is data address detection is defined by RFC 4862. So if you're interested in the RFCs at all. All right, so this basically sums everything up. So I summarized much of the RFCs. I thought I summarized the function of most of what the neighbor discovery protocols functions are, just to give you an idea, but that's essentially how SLAAC works. It's done primarily through the neighbor discovery protocol, which is nothing more than ICMP version 6 messages that are sent out through router advertisements, neighbor advertisements, and neighbor solicitations. And primarily neighbor advertisements and neighbor solicitations are used to detect whether or not you have a duplicate address on your local network. And it's the router advertisement that is primarily responsible for giving the IP version 6 host the information it needs to build its globally routable IP version 6 address. So a lot of people draw similarities between IP version 6 SLAAC, and if you're familiar with IP version 4 APIPA addresses, a lot of people say, well, isn't that basically APIPA and IP version 4? We know that IP version 4, when you get an APIPA address, is 169.254/16. It's a Class B address, but that address and private addresses in IP version 4 are not routable. A router looks at the destination IP address and says, this is a private address, I'm dropping this packet, I'm going to do Michael Bay and blow it up, and it's not going anywhere, all right? That's what's happening, okay? But the IP version 6 that SLAAC creates is routable, all right? And allows that device to communicate with other devices elsewhere on the network. It's a beautiful thing. I really like it. It's riveting. If you read the RFCs, you will not fall asleep. You want to read it to the end, okay? I can somewhat promise you that. It depends. Depends how much coffee you've had. All right. You guys are lucky you work for Wegmans. I'm sure they give you lots of free coffee, right?
You would think so.
Yeah. So are there any questions about SLAAC, stateless address auto configuration, or how it functions, or... So it doesn't preclude the need for a DHCP server, but it at least picks up some of the slack that DHCP 6 or DHCP version 4 servers need. Yep.
So you said like North America has its special prefixes.
I thought
Something like that?
I thought ICANN passed out prefix 2100 in North America.
Okay, so if I'm in North America and I don't have that prefix, I won't be able to use the internet with that address. Is that what would happen?
No, it'll probably look like you're coming from another country.
Okay, but
I'm sure you could do a VPN and spoof your IP from somewhere else if you wanted to,
routing
but
would still,
they're passing. I shouldn't say that you have to use that address if you're in North America. ICANN is providing that block of addresses to the North American ARIN,
Right,
the regional internet registry.
yeah. So when my ISP gives me a public IP,
That's what you're going to be getting. It doesn't mean you can't use some other one. It just means that what's going to be managed by these registries is geographically defined. So, is that it? We're done? Okay, cool.
All right.
All right. I got 2 minutes to spare.
We started 2 minutes early.
Oh, I did? Okay.
I don't know. I'm just kidding.
Thanks.
Food break when we take it.
Warm up.
Thank you, Garrett.
You're welcome.
Garrett, do you want your mouse?
Sure.
All right, I'll bring it when I come back.
Man, I would
I'll grab it
send
later. I
that
don't
back.
want to hold you up.
I'd send them both back. I want a whole store for free. That's cool because
mine does really well.
that's like
Up until
so I
should have done that.
So
So I've been on the router. I'm going for an hour and a half while on my own. At 9 o'clock, I have to be
Bill's on everything else.
Online,
So I don't know if I have to, I'm sorry, but
I can think my way through it. I can sign my way through it a little bit.
So I'm just gonna tell them they
I've never seen
I realized like everyone got speaks the entire time. Like I was like, whatever.
You don't have to sign, just talk. When the interpreter leaves, yeah, that's right.
And then put some bus relevant unique identifier with it. Ah, this is fun. So like building, switchboard, MAC address. Then go through that data.
How long is it gonna take? 3 days.
Total point is
Yeah. I'm hoping to be done in like 15 minutes.
it doesn't matter
Alright.
because
That was
within the same plan,
I need like.
and if it's not in the same plan, it doesn't matter.
Great flight.
Okie dokie, ladies and jelly spoons, as Bruce Hartpants frequently says. My slides are my own PowerPoint thing I made on the internet with some JavaScript library I just discovered is no longer supported.
Oh, that's neat.
But it looks cool.
You rebuild the wheel for no reason.
I did not. I copied the guy's CSS sheets, grabbed his library, and just rethemed the text a little bit.
Yeah, I do that with Google Drive every day.
So you use CSS sheets. Do you also use PIN numbers and ATM machines?
No.
No.
Yeah, Garret loves his big cards.
Ah, damn it. Alright. Let's do this. I'm hoping to be done like 15 minutes or under. Won't put you to sleep like Garret. Alright. So, this evening, we're going to be talking about securing your CentOS box with Google Authenticator. I'm Nathan J. Lichtenstein, and today's date is April 16th. I like to go over everything on my slides. So, first and foremost, let's just talk about some common authentication methods you're going to see if you're SSHing into a box. Obviously, there's no password, which is probably the worst idea possible. Or like root login, 2 things you should not be doing on your SSH sessions. But 2 of the more common ones you're going to come across are password authentication and key-based authentication. I know the back row right now is comprised mainly of security students who are judging me extremely heavily, but it'll be fine. So, based on the few discussions I've had with security people, obviously password by itself is going to be less secure because you're going to be more susceptible to things like rainbow table attacks and other things that I understand what the words mean, but not the mechanism of, because I am a lowly networking student. Then when you're getting more towards your higher security, you have your key-based authentication. Just kind of go over it. Key-based, you have your public key and your private key. Your private key is like the keys that you have in your pocket, and that interfaces with a public key that you can then use to unlock it. Just at a really quick, high-level cursory glance. And it is encrypted. You can set the different levels of encryption. You can do 256, 128 if my math is still right, and so on, AES, RSA, all the different cool algorithms and stuff. The thing I find, mainly because I'm lazy, and maybe mainly because I'm a networking person, but sometimes I find managing multiple keys can be a bit of a pain. I like to do the cringeworthy thing where I just sync them with Dropbox to my multiple computers. I'll let the back row glare into my soul for that. But frankly, I manage my own web server, so what else do people really care? But sometimes it can still be a pain if I don't have my laptop, or it's the world's not all about me. If you don't have your laptop, and you need to quickly SSH in, or something like that, and you don't have your key, and you don't really feel like downloading it, maybe you're on a lab computer, and you don't want to be fully opening yourself up and exposing yourself just using password, a really nice intermediary solution is using Google Authenticator. For those who don't know, Google has this great app. It's their Authenticator app. And basically it acts as like an RSA token that you might have seen before. You'd have them like on your keys. I know growing up my dad had one for work. And it just cycles through a PIN number that accompanies your password. Let me flip back there. So the really cool thing with this tutorial is that you can implement Google Authenticator as a login stage for your server. So it's probably not as great as keyed authentication, but it's not as vulnerable as password. So I kind of look at it as a bit of a happy in-between that makes me sleep better at night. So when I go and log into my boxes, it doesn't say there were 3,600 login attempts since you were last here, which is why I did this. So there are a couple packages that you need when you're setting up for an environment like this. I'm not going to actually do a live install because that's probably about as thrilling as watching paint dry, but I will show you logging in with it. But the packages that you're going to need to go about, you're going to need development tools, which is I think 96 different packages. I'm sure I pretty much scraped this together really quickly because we didn't have a third presenter. I'm sure if you actually dig through and see what Authenticator needs, you don't need to put all of development tools in. But if you know, I forget, I think it's like 112 megabytes or something. It's not that bad. Anyway, you need development tools. You need the PAM development package. You need NTP, Network Time Protocol. You got to keep your server in sync with your phone because that's kind of the cornerstone of this whole thing is that you have expiring keys. And if your server thinks it's 8:37 and your phone thinks it's 9:42, the odds are you're never going to be able to log into your box again. I also did write set procedurally, so you can just jump to this if you really want to try it. The next step in this tutorial, you have to actually change over to the opt directory. This guy really was very insistent that you use opt, but in theory you can use any directory. You don't need wget twice. Anyway, you use wget to go out to this super long URL. I cut and paste, you can't tell. And you can just download it as a tar file down to your local box. The nice fun part is that you have to make the module yourself. You can't just do a yum install, which would be really nice. Nope. I tried and failed miserably.
This guy's guide online is faulty because he says
I might be doing it the hard way. I don't know. Anyway, you have to make the module.
Fail. Come on.
This is
How many times did you fail?
once or twice. I didn't want to lock myself out of my box was the end result. I was doing this with my live server. So my primary concern,
always tested production.
real. I actually saw a t-shirt that said like real administrators work on prod. And I take that to heart. I like to know that if I take something down, it's going down for everybody, not just me. I will be joining the Wegmans networking team in a few months, so
You're in good hands.
yeah. Anyway, I digress on my competency level. You have to do all this cool stuff, and then you can issue make install. And now for the more important part, we're just changing your directory back over to your home directory. Try this at home if you want.
What's the tilde mean?
Hate everything. This is the part where I'm gonna. All right, here's what we're gonna do. We're gonna pretend it's all installed. We're gonna do some SSHing right here live right now. So we're gonna pretend I've installed and configured it because I have. Well, that's really easy to see. Derek's out. So, in this instance, let's say I have it configured. I'm going to show you how to configure it, but in order to show you that, I have to get into the box that's already configured on. So we're going to kind of double track and back here. If I go to SSH, if you have a Mac or Linux, you can do it over the command line. If you're on Windows, you can use PuTTY or MOBA Xterm. So my secret server is right here. So, nice part is, first thing it does is ask me for a verification code. When you're working on this, you are changing around PAM, which is the Pluggable Authentication Module. Learned that in Garrett's class last week. And PAM basically implements low-level methods for authentication, either before or after, and they can restack on top of each other. So, using the Google Authenticator app, I have an entry for my server, lctnstn.com. It is my last name and also my license plate. All you gotta do is punch in your verification code. So the one coming up for me now is 162284. Hit enter, put my password, which I will not recall out loud for you guys.
Is it the same as your license plate?
And that's it. It lets you write into the box there. Moving back to the slides, just show you how that worked. I'm not showing you network trace. This is also not an interactive presentation. From the home directory, if you get in there, where we gotta go now? So we gotta go Sue Nathan test. No. Okay. Let me make sure this file's gone. Cool, it is. So when you're setting it up and you have it all installed, you run a really hard command called Google Authenticator. Now this guy who wrote this tutorial recommends answering yes to every question that they ask you because you'll get the most secure install. For that reason, I recommend it too. Do you want your authentication tokens to be time-based? The odds are the answer to that is yes, or else you're completely defeating the point because someone gets your authentication token once, and if you don't reload it, they have access to your box if they know your password. So the answer to that is obviously yes. Now the cool part is it generates a QR code right over the command line, which is both cool and absolutely stupidly difficult to work with. But the nice part about doing it on a projector is I have the Google Authenticator app. I use a protocol called TOTP, which if you acronym it out, it's like time-based authentication tokens, but they pick some really weird letters to shorten it with. So with the Authenticator app, you just have to come in here and you hit like an add new key. And Sean McConnell just took a picture of it. He now has an authentication key to my server. So does everybody now. So we're gonna bear with this. I'm gonna nuke that in about 2 seconds.
Either way, it's
199.067.
Did it pick it up? All right, it picked it up. So the first thing it asked me is, do I want to update my local file? It's a hidden file. I would hit yes. Your chances to prevent man-in-the-middle attacks? Yes. Do you want to synchronize with your time tokens? Hell yeah. Do you want to enable rate limiting? Another really important one. Again, hell's yes. Yes, it does rate limit as well. So in the end, that's all you have to do to set it up once you get it installed. An important thing to note is that you have emergency scratch codes here. So if your phone is down in the toilet somewhere and out of commission and you need to get into the box, you can use a scratch code to get in. So it's pretty much a hard code. It's good for a one-time use, and that is absolutely it. They recommend writing them down in a safe place. I never wrote any of them down when I set it up.
Okay, well I was going to ask you to put them underneath your keyboard, but that answered that question.
Yeah, the way that you can get around this, because Pam, when you set this up, which I will show you here, you're actually putting it into Pam for SSH, right here, Pam SSHD. So if you are consoling in, it's not going to prompt you for a code. It's only going to prompt you for a password, which is a nice, quick way around that. If you're using a cloud provider like AWS or Cloud at Cost, that's what this box is. Don't laugh at Cloud at Cost.
Are you serious?
Yeah.
There are many things that you need to learn about Cloud at Cost.
Well,
None of them can be said here.
We'll talk later. Now I'm nauseous. All right.
Networking students, not security.
Anyway, I love Cloud at Cost because it's cheap.
They were just giving out free boxes at one point.
I know. I have 2 of them.
Yeah.
And I paid for 1. Anyway, you can go in, set it up on your authenticator there, and that way if you forget it, you can go into the console over the web via Cloud at Cost or AWS, and it gives you a virtual console, that way skirting your way around. The last thing you need to do is go into the good old Etsy SSHD config file and enable challenge response by just flipping that to yes. A quick way that you can do that if you use Vim or Vi or anything like that, because those are the 2 I use, you can just do escape / and then type it in and it'll take you there really quickly. That was a really quick down and dirty crash into how to do this. I recommend doing it. I usually don't recommend security things, but this thing I understand and can get behind. So do that. I guess don't use Cloud at Cost is what I have learned from my audience this evening.
Don't use Cloud at Cost for anything that isn't a burner box.
Shit.
Yeah.
It's
so
NSA.
I would definitely recommend switching to DigitalOcean for whatever you have posted on Cloud at Cost.
But I have like
now.
$80 invested in that.
Yeah.
Anywho, I make great decisions is what we've learned this evening.
Yeah. Also, Cloud at Cost, you have to fight for CPU cycles too. It's a side project put on by a Canadian ISP.
I know, that's why I trusted it. Mike Salsom told me about it. Anyway. That is my presentation for the evening. I'm what they like to call a time filler presenter when we can't find a third person to talk. Sean.
I have a question. So do you know how to set this up for, because I've done it in the past, but I've only able to do it like per account. Do you know how to do it for every account in the box without having to go through?
No, because I actually looked into this because when I created that Nathan test account, I purposely didn't set up Google Authenticator at first. And when you go in, it just asks you for password. It doesn't try verification, but even if you put the right password in, it will not let you through because you've edited the global PAM file and also challenge response as well for SSHD. But I think that is actually good that you can't do it globally because then everyone would be sharing the same time-based authentication key, which again would probably be stupid. So it is good, and that's also the only way that your users, if you actually roll this out on a large scale, can get that on their devices. They actually have to scan that somehow magically generated command line QR code, his or herself. Any other? Go for it.
Does this have any other implementations besides just for SSH?
Yes, so Google Authenticator and TOTP, time-based one-time password algorithm. We're going to use a good resource here. You can use it for a whole host of different things. A lot of major service providers offer TOTP time-based keys. Dropbox is a big one. Microsoft does as well. Obviously, Google does because they're right behind it with an app. So you can use it as a form of two-factor authentication across the board. I think I have like 8 or 9 TOTP keys synced to my phone at any given time. And I don't have a passcode on my phone. And I really have to make better security decisions, folks. I'm afraid I'm going to be found dead and they won't be able to open my phone up. So, anywho. So you can use it for a lot of different things. There are actually like websites where you can petition different companies to start supporting TOTP keys. Big one I would love to see is like Amazon supporting this because I can buy a lot of things just by logging in with the password, and I'd love to see some kind of two-factor there. It definitely is easier than waiting for a text or an email confirmation to come in, like if you're using your bank or something. But even with it feeling that easy, sometimes like, oh, I have to go all the way to my car to get my phone now so I can SSH into a box. Because I also leave my phone places. All in all,
No password.
with no password. All in all, this is a great security recommendation from a terrible security person. And any last questions, comments, concerns, thoughts, feelings, emotions, or if you just want an autograph, let me know. Other than that, thank you for coming to our second set of Tech Talks. Thank you, Tim and Eric, for teaching us about caffeine in the enterprise. Thank you, Garret Arcoraci, for doing you. All right, grab some pizza. Sorry it was late.
It's gone.
Oh, awesome. Write Steve Zalora a sarcastic thank you email. And have a pleasant and rewarding evening. And thank you to our interpreter for signing through this for 2 hours, because I'm sure that was quite a task. All right, swell folks. Have a great night.